Bismillahirrahmanirrahim. The last part we spoke about the limit of a vector function. And we gave example how to find the limit of a vector function by finding the limit for each one of the components. And we gave the properties of the limit. I stated all of them. And we said that the limit of CR1 equal to CL1, where L1 is the limit of the vector function R1, and the limit of the sum of two vector functions equal to the sum of their limits, and also the limit of their dot product equal to the dot product of their limits. In this part, we are going to give some examples about these properties. See that given that limit of R1 as t goes to A is given by I minus 2j plus k. And limit of R2 equal to 2i plus 5j plus 7k. Let's find A. I need to find the limit of the minus 4r1 of t plus r2 t as t goes to a. So I need to find the limit of minus 4 multiplied by r1t plus r2t. So all what we need just to apply the properties of the limits. For the first one, it is scalar multiplied by the vector function r1. So the first one will give me minus 4 multiplied by the limit r1t plus limit of r2t as t goes to a, which is equal to minus 4 multiplied by limit of r1 is given by I minus 2j plus k plus limit of r2 is 2i plus 5j plus 7k. So this is equal to minus 4i plus 8j minus 4k plus 2i plus 5j plus 7k. Then we add the component wise or the component of these vectors. I will get the first one with the first one minus 4 plus 2 is minus 2i. 8 plus 5 equal to 13. J minus 4 plus 7 equal to plus 3k. So this is the limit for the given question, minus 4 r1 plus r2t. Second one, B. find the limit of R1T dot R2T as T goes to 8. This was the third property, that the limit of their dot product equal to the dot product of their limits. So this is equal to L1 dot L2, which is equal to L1 was given by this one. 1 minus 2, 1. I will use the notation for greater than or smaller than. Minus 1, 1 and 2. Or not it. 1 minus 2 and 1. 1 minus 2 and 1. Dot with the second limit, which is 2, 5 and 7. This will give me, using the dot product, it is 2 minus 10 plus 7, which is equal to minus 1. So the limit of their dot product equal to minus 1. So this is the idea of finding the limit for vector function. Just we need to find the limit for each vector, for each component, or we use the properties to find the limit of dot product or scalar multiplied by the vector function on sum or difference between two vector functions. Example. Find limit of t goes to 0 if equal to 4 plus t minus 4. Second one is sine t. And third one is cosine of t. Find the limit for this vector function. So the first component. Let's find the limit four plus t minus 4 divided by t when t goes to 0. Now if we substitute t by 0, I will have 0 over 0. Or no, this is not 0 over 0, sorry. It will be 0 over 0 if it is minus 2. So I will change this minus 4 to make it minus 2. Otherwise, the limit will be does not exist. So 4 plus t minus 2. If we replace t by 0, I will have 0 over 0. Then to find the limit in this case, either I will simplify it by multiply by the conjugate, or I can use the L'Hopital rule. So either to simplify it using the conjugate, multiply by the conjugate up and down to remove the square root from the numerator, or we can apply the L'Hopital rule. If we apply the L'Hopital rule, And I will differentiate the numerator and the numerator. So this will equal to limit derivative of the numerator is 1 over 2 square root of 4 plus t. Derivative of the denominator is equal to 1. As t goes to 0. Now replace t by 0. It will be 1 over 4. So the limit of the first component equal to 1 over 4. Now let's go to the second component. Limit of t goes to 0. Sine of t divided by t as t goes to 0. Replacing t by 0, I will get 0 over 0. This is again 0 over 0 in determinant case. So we need to simplify it or use the L'Hopital rule again. So again, by the L'Hopital rule, this is equal to limit of derivative of sine is sine of t divided by 1. Now replace t by 0, I will have 1. So the limit is equal to 1. For the third component, I have cosine of t. Let's see. Equal to 1. The limit of cosine of t as t goes to 0 is equal to 1. So this will give me now the limit of the vector function is equal to, first one gave me 1 over 4. Second one is 1, third one is 1. So this is the limit of the vector function. It is 1 over 4, 1 and 1. So this is how to find the limit of a vector function. So after we are done from the limit, we can speak about the continuity. I will give just the definition for the continuity of a vector function. A vector function R said to be continuous at F. The conditions are defined. One is defined. Two limit exists. Set condition that limit equal to the value of the vector function at t equal to a. Limit of the vector function r of t as t goes to a equal to r of a. So if the three conditions are satisfied, then the function or the vector function is continuous. For example, say that given function r of t equal to to discuss the continuity of this function at t equal to 0. It means that we need to check the three conditions. Are they satisfied or not? So let's see the first condition. R of 0. Is it defined or not? It means that I need to check the component of the vector function one by one. So let's start with the first one. I need to check the value of the vector function at t equal to 1. If we go for the first component there, sine of 0 over 0 is undefined. We cannot divide by 0. In this part, we are not speaking about the limit. We are speaking about the value of the function, not its limit. So if we replace t by 0, the first component is undefined, which means r of 0 is undefined. T equal to 0, which means that the first condition is not satisfied. So r of t is not continuous at t equal to 0, because one of the conditions is not satisfied. So the function or the vector function is not continuous at t equal to 0. So to find the continuity of a function or discuss the continuity, we have to satisfy the three conditions. R of a is defined, limit exists, then the value of the vector function and the limit must be the same.